Alright engineers, I wanted to make a quick video running through how to do this ANOVA analysis in Excel and kind of what all the numbers mean. So I have this data set here. This represents 3 groups of students in a class, each studying a different way. And we might use an ANOVA analysis to see if any of these groups are different from each other. I mean, it won't tell us which one. We'll have to do a post hoc analysis to figure that out, but we can dive in to doing this analysis. So the easiest way to do this analysis is to use the data analysis toolpack. So I'll just go in here, go up to ANOVA, single factor ANOVA, and I can select my input range. I've already selected it there. I need to make sure I tell it that I have rows labeled in my first row and where I want the output to be. So I'll put the output, put it right here. This is going to go ahead and run the ANOVA analysis for me. ANOVA is comparing the variance, and it tells you here that it's comparing the variance, to do an analysis of variance between the groups and within the groups. And so it's calculating these variances between the groups and within the groups, and then calculating some statistics and using these statistics to compare this to an F statistics curve and give us the integral of that, which is our p-value. And if our p-value is lower than our alpha value, then we reject the null hypothesis that all the groups are similar, and it tells us that at least one of these groups is different. And then we can do our post hoc analysis to figure out how these differences between the groups might look. Here we have the variance of each group, and I just want to show you how to calculate this real quick. So the average of each group is, we can use the average function to find the average, and these match up perfectly with these values here. These aren't formulas, so it's kind of nice to know the formulas. And the variance, if I wanted to calculate the variance, the easiest way is to take each of these numbers and subtract it from the average. So we'll just subtract it from the average, and then we square it. And so that's our variance. And so I can do that for each of these columns here. And those are my individual variances, and I can sum them up. The formula for variances, I can sum them up. And then, so let me sum those up. And then we divide by the degrees of freedom. For each of these columns, there's 5 data points, and so our degrees of freedom would be 4. So I could do equals this divided by, we just use formulas here. So that's where these variances come from. One thing that you'll note is if let me insert a column here. If I add up, just before I divide by the degrees of freedom, if I just add up the sum of all the variances, then something went wrong. This formula didn't copy over. That was silly. So now these match. But if I add up the sum of all these variances, you'll notice that, so I've replicated. Let me just go ahead and highlight the numbers that I've replicated so that we can keep track. I've replicated all these numbers this is a really important one, so I'll change colors here. I've replicated the variance between the groups. And so that's telling, sorry, within the group. So that's how much variation is in each group. The next thing I want to do is I want to get the variance within, between each group. And so I could take the average of the averages. That's my average of my entire data set. So if I took the average of this entire data set, I would get the average of the averages. And I can then look at the variance of how each group compares to the average of all the groups. And so let me do that. So that's those are the averages that I have. Now, one thing I have to note is I have to multiply. Each of these happens 5 times because each group size is 5. So I'm going to multiply all of these numbers by 5. And then if I add these up, you'll notice this number matches the variance between groups. And if I add those two numbers up, I'll get the total variance in this data set. And if I wanted to get the total variance, I could do the same thing I did here. Here I calculated each of these columns subtracted from that column mean. Now I could do the same thing. I could do each of these data points divided minus the total group mean. So this is the total group mean. I'm going to square it. So I could do that for this is like the total variance of the entire class. Whoops. And if I added all that up, I get this number here, the total variance in this data set. And so basically it's saying, okay, I have this class, I have 15 students in this class, they are divided into groups of 5, and each studied in different ways. The variance, the variation was this number here, close to 200. 114 of that came from variation between groups, and only 85 of that came within each group. And so there's more variation between groups than within groups. And so what that's going to yield is a value that tells us that there is a difference. We have sufficient statistical evidence to infer that there is a difference in at least one of those groups. If I wanted to go a little farther, I could do a couple paired t-tests of each of these using the Bone-Ferroni correction, and I can figure out where there are significant differences. I wanted to quickly tell you that this number, the degrees of freedom for 2, I could calculate that. I have 3 groups, so 3 minus 1 is 2. That's my degrees of freedom between groups. And then within each group, we have 5 in each group. Each of those is actually 4 because it's n minus 1. And so 4 times 3 is 12. And so I'd have 12 within each group. Total would be 14. 15 data points minus 1 equals 14. And 2 plus 12 equals 14. So these numbers here, I'm just dividing my variation by my degrees of freedom. My variation divided by my degrees of freedom. And then this F statistic that I'm using and I'm calculating, I could calculate just by taking the quotient of those two values. That's where that comes from. And then I could calculate the p-value is equal to using the F statistic I just found, and I have my 2 degrees of freedom, 2 and 12. That's where that p-value comes from. Hopefully that's helpful, kind of demystifying where these different values came from in the ANOVA table.